One more boom exists to help operators, builders, and future founders understand, position for, and build into the next boom.
A lot of AI projects start with a sentence that sounds productive. Let's write a better prompt. And to be fair, the prompt matters. Clear language matters. Context matters. If you give a model a vague instruction, you should expect a vague or inconsistent result. But a better prompt won't fix a job nobody has defined. It won't decide who owns the outcome. It won't tell you which information the model is allowed to use. It won't prove the answer is right. And it definitely won't give the model authority to make a decision your organization hasn't approved. The prompt is part of the work. It is not the plan. Let's use a completely fictional example. An industrial project team says, use AI to review our weekly field notes and tell us what will delay the job. I can see why that sounds useful. There may be hundreds of notes coming in from different functions. Somebody is trying to find schedule risk before it shows up in the report 2 weeks later. So the first instinct is to open a model and start tuning the wording. You are an expert project controls analyst. Review these notes. Identify every delay. Rank them by impact. Give me an action plan. That prompt may produce a clean answer. It may even look impressive. But look at how much authority we just smuggled into one paragraph. Which notes can it read? Does it know the current schedule, or is it guessing from old language? What does delay mean in this test? Can it separate a confirmed constraint from somebody's concern? Who checks the result? And what happens when the notes contain conflicting information, personal details, commercial information, or something that should never have been sent to the model in the first place? Those aren't prompt polishing questions. They are implementation questions. This is where I would stop and build what I call a context-to-constraint brief. It sounds more formal than it is. The point is to get the important decisions out of somebody's head and onto one page before the test starts. Start with the job, not use AI. What exact piece of work are we trying to support? In this example, the job might be identify candidate schedule constraints inside a small set of synthetic weekly notes. That is much narrower than tell us what will delay the job. We are not forecasting the whole project. We are not changing the schedule. We are not assigning responsibility. We are testing whether the model can find a specific kind of signal in information we already understand. Then name the owner. Who is accountable for the task? Who reviews the result? And what authority do they actually have? For this fictional test, the project controls lead owns the review. That doesn't mean writing project controls lead in a box gives that person new authority. The organization still has to decide who is authorized to accept, reject, or act on the result. The brief records that decision, it doesn't create it. Next, define the context the model is allowed to use. For an early test, I would use synthetic notes and a synthetic activity dictionary with known answers. No live project records, no personal information, no client data, no commercial terms, no safety-sensitive detail. That does two things. It lets us test the thinking before we expose real information, and it gives us something to compare the answer against. Now define the output. Don't just ask for insights, ask for a table of candidate constraints, require the source note for every claim, require the model to show uncertainty and missing evidence. If two notes conflict, show the conflict. If it can't support a claim, it should leave it out or label it clearly. This is where the prompt finally starts taking shape, but we still aren't done. We need an acceptance test. What would make the answer useful and what would make us reject it? Maybe every candidate constraint must point to an allowed source record. Maybe unsupported claims are an automatic failure. Maybe prohibited data appearing in the output stops the test. Maybe the model must use the required structure and avoid issuing any field direction. The exact test depends on the job and the consequence of being wrong. NIST's AI Risk Management Framework makes this point in more formal language. Purpose, Context, limits, human oversight, and evaluation sit around the model. You need enough context to make a go or no-go decision, and you need testing that reflects the conditions where the system is supposed to work. The U.S. Department of Energy has been testing the same idea in critical infrastructure settings. Its Stormbreaker work looks at the model, system instructions, prompts, skills, tools, and environment, because all of those variables can change the result. That matters. If the test fails, write a better prompt may be the wrong lesson. The problem might be the data, it might be the model, it might be a tool the model can access, it might be a bad evaluation, it might be that the job was never suitable for AI in the first place. If we change everything at once, we don't learn much. Change one controlled part, run the test again, and record what happened. That is also why the brief needs a stop condition. If the model sees restricted information, stop. If the source can't be traced, stop. If the instructions conflict, stop and route it to the owner. If the request turns into a schedule change, a field instruction, an approval, or a decision outside the test, stop. A stop condition isn't a sign the pilot failed. It is part of knowing what the system is allowed to do. There is another trap here. Organizations will sometimes say, don't worry, we have a human in the loop. Which human? Looking at what? Using which acceptance criteria? And what can they actually decide? Human review only means something when the role, evidence, decision, and consequence are clear. Otherwise, we are handing somebody a confident-looking answer and asking them to absorb the risk at the end. This connects directly to the last episode. An edge case can give the organization a useful signal from the people closest to the work. But before that signal becomes input to an AI-assisted task, somebody still has to define what the model may see, what it is being asked to do, what evidence the output needs, and where human authority begins. Capture and prompting are connected. They are not the same control. This is also the kind of exercise I am building into Boom Lab. Inside that work, I am using a software workspace with the working name Pactwell to make the request, allowed inputs, evidence, reviewer, approval state, and next test visible. Pactwell is a working name, not a launched product or proof that the workflow is finished. Where a step isn't implemented or verified, it needs to say so. A clean screen should never be confused with proof that the process works. The goal isn't to build another place where people collect clever prompts. The goal is to help a team see what it is asking AI to do, what it expects back, and who owns the decision when the answer matters. So here's the practical step for this week. Take one request in your organization that starts with, use AI to, don't write the final prompt yet. Write down the job, the owner, the permitted context, the prohibited inputs and actions, the required output, the evidence standard, the acceptance test, and the stop condition. Then write the prompt. When the answer comes back, don't ask whether it looks smart, ask whether it passed the test. I put the Context-to-Constraint Brief together as the field note for this episode. Boom Lab is still in development, and this is one of the practical exercises I am building into it. Follow one more Boom field notes for the brief, future exercises, and founding pilot updates as they are released. A good prompt can improve the answer. A clear plan decides whether that answer should matter.